Okay, hello everyone. From now on, we will move on to exercise 6C, which is about joints variation. Okay, so I think from the name of the chapter, you can imagine that it is about joining multiple unknowns together. Okay, let's do a little bit revision first. In direct variation, we do something like y directly varies x, therefore y equal to kx, and this k is not 0. In inverse variation, we do something like y varies inversely as z, and therefore y equals to k over z, where this k is not 0. Okay, so we are very familiar of these two types of variations, direct and inverse respectively. Okay, but actually if we pay attention to both kind of variation, no matter in direct or in inverse variation, we are just connecting one unknown to another. In this case, we are connecting y to x by direct variation. In inverse, we connect y with 1 over z inversely by inverse variation. Okay? So here we can see in either type of expression, only one unknown is involved in the right-hand side of the expression, of the variation expression. The x here and the z here. Okay? So in either case, we can see that only one unknown is involved. Only one unknown is involved in the right-hand side of the expression. Okay? But starting from joint variation, there will be more than one unknown involved in the expression. Let's take a look on how it looks like. For joint variation, for example, if I tell you that y varies directly as x and inversely as z. Okay? So actually we can break this sentence into 3 different parts. The first part is the y here. Okay? So this tells us that y will be the subject of our variation expression. Okay? So the second part, the second important part is y varies directly as x. Directly as x is our second part. And therefore, inversely as z is our third part. Okay? So we can see this time we are joining y with x and z at the same time. Okay? But the value of y here depends on x and z. Okay? Because y actively varies to directly as x and actively vary inversely as z. So y is the subject and it depends on the value of x and z here. So how should we write down the variation formula for this one? Very simple. We just join x and z together, okay? But there will only be one variation constant, that means k. So it will look like something like this. Y varies directly as x, so x is the numerator part. Inversely as z, so z is the denominator part. Therefore, y equals to kx over z, where this k is not 0. Okay? So here we can see that in joint variation, very important points. No matter how many unknowns are involved, they only share one variation constant. Together. Okay, so this is a very important point. Later, when we start partial variation, there will be more than one variation constants. But at this stage, in joint variation, no matter how many unknowns are involved, you can involve like 10 unknowns in the variation equation. But actually, no matter how many unknowns or variables are involved, okay, in joint variation, there will only be one and only one variation constant. That means only one k in the expression, no matter how many unknowns is involved in the expression. Okay, so that's all for this clip. Next clip will be instant drill.